Hello friends, welcome back to my YouTube channel. This is Spandana K. Today I am going to discuss a topic histogram and density plots that comes under the subject data science and visualization. Introduction to histogram and density plots. Histogram and density plots are powerful data visualization techniques that help you explore and understand the distribution of your data. These visual tools provides insights into a shape, spread, and central tendency of your data. Histogram and density plots are nothing but they are the visualization techniques where we can easily understand the distribution of the data. Whatever data you take, we can easily visualize those data through this histogram and density plots. Understanding data distribution. Visualizing the data. Histogram and density plots are powerful tools to visualize the distribution of the data, revealing the patterns and the trends that may not be easily discernible in the raw numbers. If we take raw numbers from the data, it cannot be described easily, so we cannot visualize it easily. So by formatting it into a histogram and density plots, we can easily visualize the data and we can easily understand the data. Next one is describing central tendency. These plots can highlight the central tendency of a data set, such as the mean, median, or mode, providing insights into a typical or average values. This histogram and density plots also describes the forms like mean, median, or mode. Identifying the skewness. Histogram and density plot shapes can reveal if a distribution is skewed with one tail longer than the other, indicating an asymmetric or uneven spread of the data. We can also visualize the data. We can also identify the skewness, whether the data has changed with respect to a time, how much the data has been changed with respect to a time. It is uneven or not. These are all the informations that are available from this histogram and density plots. Constructing a histogram. To construct a histogram, first we have to collect the data. Like we have to gather the data that we want to visualize, such as a test score, customer purchase, or survey responses. These are the example of some data. Determine the bin size. Choose the number of the bins that will best represent the distributions of your data. Calculate the bin boundaries. Set the lower and the upper limits of each bin based on the range of your data. And then count the observations, tally the number of data points that fall into each bin to create the histogram. This is the process of constructing the histogram. Choosing a bin width and size. Like how can we choose a bin based on these features? Narrow bins. Narrow bins are nothing but they capture the fine details. Wider bins reveals the broader patterns. Optimal bin width balances the detail and clarity. These are the three bins that has some advantages as well as some disadvantages. Let's see some advantages and disadvantages. Selecting the right bin width size is crucial for constructing an informative histogram. Now let's take the narrow bins. This narrow bins provides a granular detail, but it has some disadvantages, like it results in noisy or the cluttered visualization. Wider bins, on the other hand, smooth out of the data and highlight the broader trends. The optimal bin size strikes the balance, revealing the key features of the data distributions without obscuring important details. So these are the three bins. Interpreting histogram patterns. First one is peaks. Like in histogram patterns, there are three types of like patterns, that is peaks, skewness, and multimodality. First one is peaks. Identify eye points representing the most common values. So it identifies the eye points in the histogram visualization. And next comes skewness. Asymmetric distribution indicates a lack of symmetry. Multimodality, multiple peaks point to distinct subgroups within the data. In histogram visualization, there can be multiple peaks. That we call it as multimodality. Analyzing the shape and features of a histogram can reveal important insights about the underlying data distribution. Prominent peaks indicates the most frequently occurring values. Like there are some prominent peaks, like they are most occurring values in the histogram visualization, while the skewness suggests as asymmetric spread, and identifying multiple peaks may signify the presence of distinct subgroup within the data. Density plots, smoothing the histogram. Density plots provide a smooth, continuous representation of a data distribution by estimating the underlying probability density function. This is achieved by applying a kernel smoothing functions to the histogram, resulting in a visually appealing and informative visualization. The first one is kernel smoothing. The kernel smoothing functions blurs the histogram bars, creating a smooth curve that captures the overall shape of the data. Bandwidth selections. Choosing the right bandwidth is a crucial as it determines the level of detail and sensitivity of outliers in density plots. And the next comes revealing patterns. Density plots highlights the features like multimodality, skewness, and kurtosis that may be obscured in the original histogram. So these are the three smoothings that can be done to the histogram through the density plots. Advantages of density plots, smoothing the data. Now, density plots provides a smoother representation of the data distribution, making it easier to identify the patterns and trends compared to the traditional histogram. This smoothing of the data helps us to data distribution make it easier to identify the patterns. It helps us to identify the patterns easily compared to the traditional histogram. Continuous visualization, unlike the histogram's density plots, create a continuous curves that allows for a more intuitive and understanding of the probability density functions. Comparison of distributions. Density plots make it straightforward to compare the distributions of multiple datasets, enabling you to identify similarities, differences, and the potential outliers. This comparison of the distributions helps us to compare the data that they are similar or that are different from each other. And then the consistent scale. Density plots have a consistent scale that represents the probability density, making it easier to interpret and compare the relative frequencies of the different data points. This consistent scale helps us to compare the different frequencies of the different data points. And the next comes comparing distribution with density plots. So we compare the distributions with help of the of these density plots. Density plots are particularly useful for comparing the distributions of two or more variables by overlaying and density curves. You can easily identify differences in shape, central tendency, and spread of the data. This allows you to quickly spot patterns and make meaningful comparison between groups or conditions. This comparing distributions with density plots helps us to find out the difference between the datas of multiple datas. Applications of histogram and density plots. Quality control. Histograms and density plots help monitor manufacturing process by identifying deviations from the target specification and detecting potential issues. And the next one is sports analytics. This visualization aid in analyzing the players' performance data, identifying the patterns, and comparing the distributions across the teams or the season. Sports analysis is nothing but it is used to perform the data that are related to the players. Marketing insights. Business leverages histogram and density plots to understand the customer behavior, preferences, and the distributions of the key matrices like sales and engagement. This marketing insights are related to the sales and other engagements. And next comes biological research. Scientists use these plots to study the distributions of the traits such as body size, gene expressions within and across the populations. These biological results are related to the scientists, how they're going to work, and what are all the data they collect, and what the collected data can be applied to the histogram and density plots. So these are related completely to the biological part. Conclusion and key takeaways. In this presentation, we have explored the power of histogram and density plots to understand the distribution and the patterns within our data. These visual tools offer invaluable insights that can inform your analysis and decision making. So this is the end of our presentation. So we have learned what is histogram, or like we have learned basics of the histogram and density plots. Thank you.